Okay, so good morning. Actually, to you, good afternoon. It's my pleasure to have this opportunity to share some of the work on the user modeling and actually some kind of the user observation. That's kind of the exploration for us to check what the users will tell us. And always we will find something surprising and something not as what we had ever expected. So, and that is also what I would like to share with you. I have to say that this kind of exploration has not stopped. So maybe we will find something different from what we have observed today, but that's really a fancy and exciting way. And I hope that you will also enjoy some kind of the not only enjoy my presentation, but also enjoy this kind of work. And then we will have more colleagues to working on this way. So my talk is what users tell us is kind of the users understanding and modeling for personalized recommendation. And I'm from Tsinghua University, but this work, the whole presentation is composed of several work and my co-contributors, including my PhD students Hongyu Lu and Chenyang Wang, and the postdoc Wei Zhima, and two of my colleagues, the long-term collaborating colleagues, Yiqing Liu and Xiaoping Ma. And also the last work I will present today is also the joint work with Martin Derek. Okay, so actually, you know that there are quite a lot of things to say for their user understanding and modeling. And also the evaluation. But you know that we have the limited time and I won't want you to be too bored by what I'm talking about before your Christmas holiday. So I just think about what is the most valuable things and maybe something different from what we had expected. Or maybe you will be interested in. So I summarize those into 3 questions for the personalized recommendation in users' perspectives. The first one is, are user behaviors always inspiring or annoying? You know that when we do the user modeling, we just want to say that we believe in the user's own choice. We just trust what the users tell us based on their either words or their implicit feedback like clicks and favorites and like and comments. Actually, how much to what kind of extent those kind of information is helpful, or is it full of noise, what we are facing at? So that is the first question. And the second question is that, how can we model users' complex intents? You know that to try to understand the user is one of the most complex things in the world. Even for human beings, it's hard to tell whether you know what the other one is thinking of. So how can we make our computer programs know about that? But actually, to personal recommendation, you need to know that kind of information. So is it possible, and how far can we go there based on our explorations? And the third one, you know that for personalized recommendation, the most fancy words is personalize. And personalization make us think about it is something about subjective, something about the users themselves. It's kind of the secret about the user's preference because only he himself or herself could know about what he or she does want. But is that truth? Is it always, or is users' preference always a secret? And it is only known by themselves. And we want to go one step further to check, is it any chances for us or for our computer programs to try to understand users and try to predict or try to perceive the user's preference. So that the 3 questions focus on the understanding, the modeling, and evaluation in different aspects of personalized recommendation. So let's go firstly to the user understanding. Actually, you know that are quite a lot of work about the user understanding. And today I'm mostly talking about our progresses in recent 3 years. So some selected ones. The first one is about the user behavior and the satisfaction. Well, actually, when we are using our mobile phone, for example, for the news streaming recommendation, actually we have some clicks and we will skip on something. So people take that as the implicit feedback. And we use those kind of the implicit feedback like click is a positive example and non-click one are the negative ones. And then we train our model and do the system evaluation based on, for example, CTR. That is one of the most important thing for the click-through rate. And sometimes when we are working at the news reading or music or video watching, we are also talking about some dwell time, etc. But actually, everyone, you must believe me and you must agree with me that click is not always equal to like. So what the user clicked doesn't mean he just like it. Maybe he's just cheated by the title or by the images here, and maybe then he just click and he feel disappointed and close that page and go back. And hence CTR doesn't mean the satisfaction. Well, um, we did some user study for this kind of work. We want to know to what extent the user's behavior is believable or trustworthy or not. So previously, people always talking about the click and dwell time prediction. And actually, the reason behind is that they want to recommend the result that this article attract you to click. But actually, it will take some problems and such as click bias and what the behavior people always use for analysis is the click and dwell time. Actually, what we think that is most important is the final goal is for user satisfaction. And we want to recommend some articles, for example, in news streaming, that these articles satisfy your interest and your information need. So to do that, for this purpose, we need to take the complex information like the time, the scenario, the news and mood information into consideration. And what behavior we could use is not only clicking, but also the rate and skip and comments. But due to the time limitation today, I will mainly talking about the click behavior, and we have some other separate works on the read and skip. You may find that click, you may saw that click is an old thing that we have already started for quite a lot of years. Is there anything new? Please just wait for a few minutes and maybe you will find is there anything new. So this is the methodology of what we did for the user study. We just think about the user's information acquisition in the news streaming, and we separate them into 3 phases. The first phase is the before rate that user have already been shown this list of the news, and then people who read the news itself, he just get a slide in the get a slums have the title or maybe the pictures and images, and sometimes you will also have some videos, and then he click on that. So just when he click it on it, but before he read the news, we call this is the before rate. And when the user so for before rate behavior, we just have the estimation. Actually, the users, they have some estimated preference, what he expected to receive from this news. We ask the users to tell us to annotate what he feel about this news, predicted whether it will satisfy his preference. And then for the second stage, when the user is reading the news article detailedly, then that is After he finish his reading behavior, he want to go back to the list. So then just before, when he click back or when he click the close the window, then that is just have the trigger another questionnaire for the user. We call this the after read phase that, and now we have the user's temporary preference to these news articles. And we also have the user perceived quality about this news. And then user went back to the list, and then he may go to another news, to the before read and after read. And then finally, when the user have finished this reading session, he or she is just satisfied or unsatisfied just when she want to finish that, before he or she just leave the app. Then we just trigger out the third questionnaire asking the user's preference. We will randomly render all of the news about in the previous list and ask user to get to show his or her preference on how much do you like the news from 1 star to 5 star. We call them the post-session stage. And here we got the final user satisfaction, and we believe that is the user's true preference, not only the temporal preference, but his preference may be changed afterwards. Then that is a final thing that have left to the user's idea brain. So in this way, we just modeling and just trying to study the user preferences versus topic, content, quality, and interaction context. And yes, actually, we find quite a lot of interesting things, but due to the time limitation, I would like to show you some really fancy things that what surprised me. The first one is the click and preferences. Well, okay, so the first one is that click is not equal to like. That is what I've already know, but to me, what surprised me is the percentage of this way. You show that, or for all of the here we take the post, we always take the post test preference as users objective and the final preference to the news and articles themselves. And for 1 star is the exactly not satisfied. Please don't show me that again. And the 5 star is the most satisfied. I do like it is perfectly match my interest. So you will show that for all of the clicked, the clicked news, you will say that altogether 58% of the news that user clicked is unsatisfied. It's not the users what the users want. Even for the here for the 3 means that just so. It's just okay, but that's not good enough. And we only take the 4 and 5 as the good ones. That percentage is pretty much higher than we had ever expected. More than half of the users clicked information are not exactly the satisfaction signal, but actually to our research and applications, we always use this click information as user satisfaction. That is kind of with quite a lot of noise. It's really noisy, and because not more than half of those information are not what the users want. And this work has been discussed in our SIGIR 18 paper. That is the first work on our user study on the news streaming. And we go a little bit further on the different phases. For example, here, the user behavior and satisfaction, let's say what happens between different phases. Is there any gap? So the first one is the before read preference. So actually, you know that we think that when you, why there are so many unsatisfied results, just for final result, is it just kind of the change of the user mind? Actually, this result tells us it's not just change their mind. So actually, before read preference means that when your user decide to click, decide to read the news, and he or she did not read the news yet, has not read the news yet, actually, he guys already know. For example, here is the score 2, and this is the score 3, means that more than 30% of the user's preference is less than 4. That means I just click that news and I already know that this news is not good enough. I will unsatisfied with this news. I don't like this news, but I still would like to click on that. Really interesting that. So not in all the cases that users are cheated. No, they are not always being cheated. They just know that it's really bad. It's not a good news, but I do like to read it. So that is the first gap. We believe that it's kind of the gap between click and the before read preference. And we have some further analysis. And if you are interested in that, you can read that paper. But actually, we feel that this gap driven by the topic preference and the quality of the news, because quite a lot of the news have some have some kind of title for persuasion. You have already know that it's just the title, try to attract my interest, attract my rating. It's not quite a good news, but I do want to just supply. I'm just curious about what they're talking about. And the second phase, the second phase is, so that is the second gap between the first and the second phase, before read and after read preference. You will say that the bad news is that what satisfied us has been dropped greatly, significantly, and there are more news that users feel unsatisfied and really don't want that kind of thing. And the average preference has been dropped from 3.7 to 3.4. So we find that for this kind of the gap is mostly because of the quality. And the last one, after read preference and the post-task preference, you know that the unsatisfied rate is continuously decreased, and the unsatisfied rate is continuously increased, and the satisfied rate is continuously dropped, and the average preference is just dropped to around 3. That is just so. Well, what makes those after read gap between after read to the post-task? We think that after read preference is just a temporal preference. It has quite a lot of impacts from the contextual information, and we have some post-task preference. When we think it over again, after all of the tasks that's finished, when you turn off your mobile phone, you just sit here, oh, what the ugly hour I have already spent. It's kind of a waste of time. Sometimes people will just be stuck in such kind of the situation. But one of the interesting thing is that for the users, most satisfied thing, the most favorite thing, the 5 score things have maintained in a stable range or even a little bit higher. So that kind of really what the users really wanted is easy to capture by user himself, and it's not quite changed so much. Well, but actually we have already know that with the user's click doesn't always mean he just prefer that information. And let's go a little bit further into the quality effects. Well, that is a pretty bad news. Well, when we take the quality into consideration, here the EQ means the expert quality, means that we ask experts to annotate the quality of each news articles. And we found that in the experiments, during the experiment period, and actually we find that for high quality news, the click probability is much lower, significantly lower than the low quality news. Well, that kind of the gap is really big. And we even add the position information into there, and we get that really exciting news, and we feel really sorry for this kind of the curve. You will see that the blue lines are the low quality ones, and the right lines are the high quality ones. And here is the top position, the top 1, top 2, and the top 3 to top 15 position that the user clicked. Well, you will say that the low quality news always receive higher probability to click than the high quality news. That is really the bad news, sadly, that those bad things, that bad news just attract much more attention from the users. That is not by one user, but by a group of users. So that is kind of the, so when we got this result, when I'm giving some talks to the audience who are not in computer science, who are just in some general domain. So what I want to tell about the users, that you know that everyone, including you and me, we are we are giving the great impact to our recommender system, because recommender system rely on the user clicks greatly. And so the more you clicked, the more they trust in the results, and they will think that they are what you, what I, what everyone like, and then they will raise the ranking, and they will try to recommend more things like that. But that is not only the fault by the recommender system itself, but also some result driven by you and me, by everyone, by every user, that we gave the too many clicks on those low quality ones. Yes, that is based on the large scale user log. Well, we monitored the user log. We just randomly sampled the real news streaming user log, and it including more than 1,500 impressions per news on average. So that is really a large scale log analysis. And we find that high quality news click rate is about 8%, but the low quality news click rate is only is about doubled, is 15%. That's really what surprised us. So here, the quality is not the expert annotated quality, but what we have detected by some clear and simple rules for what makes the quality, how to predict the quality, like the content and the semantic similarity between content and the text, and also the title and the content, and also kind of the like the kinds of the attracting words that people would like to use, something like surprise, or you must know, or please recommend to please go spreading this news to others, something like that. So that is kind of the findings, that low quality news have higher click probability. Well, is that the true bad news? You see that we feel a little bit disappointed, because we think that it just beat some kind of the basic assumption about the reliability, about the click information, what we use even for those large scale user clicks. But then we go one step further later, and this work is published in SIGIR 19th, 1 year later. We think that is that something good for us, is all of the users' clicks are not reliable. Actually, we do some negative experience, implicit negative experience analysis and study, and we find something good and encouraging, and to let us to know that yes, the user's satisfaction, the user's true experience is possible, is potentially, and it actually is able to be captured automatically. What we did is also we did some kind of the user study together with the large scale user log analysis, and that including around 300,000 sessions from 5,500 users. While we asked the user, actually there are some news. When you click on that, you can when you look at that, if it gives you negative experience, you don't want to say that again, you can click on this feedback, the close, and then you can give your reason for negative feedback. For example, is that a very poor content, or it's already saying, or I dislike the author, or something others that you can type in your feedback there. You know that we have the really lazy user. I myself is also kind of lazy. Even if I don't like this news, I don't want to touch that button to tell you I don't like that. I just say, oh, what news? It's really bad. And then I just slide down for another one, and maybe it's repeated for many times, and then I will give up for that app. So that is the most cases, but some users, or sometimes I will give them some, if I don't feel that is tolerable, and then I will just give this feedback angrily to say that, please don't show that again to me anymore. Then we could get some really sparse user negative feedbacks, but since we have quite a lot of large scale logs, we still have enough feedback for the user negative feedbacks. And then, so we do some analysis. We use some methodology like the causal analysis to do this kind of analysis, that we do some propensity score matching. We try to isolate some confounding factors, and we just check that we find the most matching before click behavior, and then we found some pairs that is negative, one for negative experience for this one, and another one for non-negative experience, and we check for the after click behavior, and trying to do this causal effect analysis way approach to modeling whether is there anything changed or anything happen for user behavior after the user have a negative experience. Well, firstly, I'd like to show you some result on intra-session effects on user behaviors. That means, for example, this is a session, and now the current interaction, it is negative or non-negative, and then what's the impact for the subsequent interactions in current session. And we will find that when the negative experience lead to shorter rating, that if the current experience is non-negative, then the afterwards in the following sessions, that would be on average 87 seconds. But if it is a negative experience, when they have the similar pre-click situation, and also in the similar position, not the position bias, they have earned for the similar remaining session lengths. And then in the same situation, that when it is a negative experience, we find that average reading time dropped greatly to only 63. So they have around 24 seconds of drop. So that is first finding. The next experience will lead to short rating indicated by the shorter dwell time. That is, the user's behavior could tell us. And we go even further to the different metrics to the user's behavior. For example, the browsing speed, you know, the higher speed is means that the user just get even faster looking through, that he will showing the less interest. And also, for example, the mean reciprocal rank means that the user last clicked on the top results. And also the blue ones like the satisfied click, average click dwell time, and also the session dwell time. Okay, so actually here, all of the blue ones shows the higher the better, means that the users are more satisfied. But unfortunately, after the negative click, all of this positive feedbacks has been dropped greatly. So this is a line of the 0, so that's below 0. And out of the negative signals has been increased greatly. So that is the second finding. After negative experience, user lose attractiveness and leave sooner. Wow, so that is the intra-session effect. And we also did this kind of the causal analysis and comparative analysis for the inter-session effect. Well, so if in the first session there is a negative experience, and then for the next session, we check about the, for example, return time, how long the user will come back to the session, and the interactions in the next session, we will find that the average return time when there is a negative session for currently, the average return time is increased on average 2 and 6 hours. And actually all of the after negative experience user return later in next session and indicated by longer session return time. Wow. And also we have checked about the different metrics about the compare two set of the session. One is the current session scores when the last one is session experience contains a negative, or the last one is non-negative experience. You see that almost for everyone, every metric, they just go in the different way, in the opposite way. So that is the fourth finding. After negative experience, users have behave differently in the next session. Well, actually, that is really the fancy way that we find, although users click, when checking about the user click itself, users click doesn't always mean users doesn't always mean the user's preference. He may not be satisfied about that. But if we take multiple behavior, and if we take more detailed metrics into consideration, it is easier, much easier for us to identify what a negative experience had just happened. It is possible. And also, even for click information, when we combine with some other metrics, it is possible for us to predict the user's satisfaction. Those two kind of the prediction work has been shown in our SIGIR 18 and SIGIR 19 paper, but that part for modeling part, I just skip over that and only show the user study part. If you're interested in that, maybe you can read the paper a little bit more detail later. Wow, so that is what we find from the user's experience and user's behavior. When we're trying to understand user behavior, we find that it is not just a simple way. It is not just simply do some counting, count the user's number of clicks and calculate this click-through rate. That's enough. No, it's not enough. We need to take the contextual impact into consideration. We need also think about the quality, and we need take, for example, the dwell time and all of this kind of the metrics, not only the click, but some kind of the different metrics on user behaviors to guide us for the better user understanding. Then it is possible for us to do the user modeling. So that is the first part I want to show and I want to share. And the second question is that how can we model users' complex intent? So that goes to the modeling part. So actually, you know that for almost every user study work, they will have some kind of the way to model. So And hence, I won't tell you, I won't tell all kinds of different modeling ways, what the others and what we do, but I would like to show you something. I think that is a series of work, and we go that way step by step and later more and more gradually, and we take more information into our consideration, and we're trying to model the user intent more complex than the initial case. So that is the initial work. Two researchers for work that has been led by one of my PhD students, Zhang. And this work is in our published in Nature W19. And this work is we check about the repeat consumption, because we think that that in users' behavior, in either intent previously, most of the work are focused on recommending different things to users, different items, that if the user had already consumed that item, not only in e-commerce but the news, then we would just throw them out. We wouldn't recommend that again to the user, but actually in most cases, we have do some study, and that study has been shown in our work in the paper that more than 80%, at least more than 80% of the users have the repeat consumption intent, and actually in users' behavior, especially in the e-commercial scenario, people have quite a lot of the repeat consumption. For example, well, they have the two examples about the baby diaper and the feeding bottle, and we find that for baby diaper, that the red curve are the users' purchase tendency, that initially people want one types of the baby diaper, and then that greatly decreased here. Okay, so if you have some baby, you had ever have some baby, now they have already grown up, you must won't forget those terrible days that you have to change the baby diaper maybe one day for more than 10 or more than 20 pieces. You will feel, why? That is kind of a repeat consumption. Why it just dropped greatly? Well, to the user behaviors, because every mother or father for the new baby, they won't just buy one pack about the baby diaper. They will buy quite a lot of them. And when, in most cases, when all of them has been used out of usage, and then you find that your baby is bigger enough, then you won't need the same size of that. You will need another item, for example, the bigger size or some other ones. And then that's kind of the cases. But actually for the feeding bottle, you buy some, and that baby is so unpredictable. Maybe the second day or the next week, they will just broken the baby bottle, a feeding bottle. And or maybe after 3 months, you think it's not clean enough, let me buy a new one, and then they will get a new one. So that is kind of the purchase curve. Well, really fancy and reasonable curves, right? And yes, we find that for those lifetime information, we can do very good modeling, and then we could try to find this repeat consumption intent. So that is some kind of the assumption for the ideal case. And we find that when we simplify things into these types of, we only take the repeat consumption into consideration, we have much better recommendation result for the e-commerce website, e-commerce scenario. And then after that, we go one step further in the year 2020, that actually for some relationships between items or for items themselves, it's not only one, we have multiple relationships. For example, we have some complement or a substitute relationship. For example, if you just buy an iPhone, and nextly maybe you need buy an AirPod because it's kind of the complement information. And so initially, when previously you have an iPhone and then your app part purchase intent is just have a higher rate, and then, but if you didn't buy it, when the time passing, it will decrease greatly. But actually, if it is a substitute of the previous product you had ever purchased, firstly, you have already buy the Power Beats, and nextly, now you will maybe just 10 minutes ago, you just buy the Power Beats, and now your purchase intent for buy an AirPods is really low. It's a negative, in fact. But actually, after one time passing, maybe several months later, your intent to buy another one to iPhone will increase greatly, and then maybe 1 year later, it's time for you to change a new one, and it's increased here. Okay, then to this work, we think that if we model multiple relationships here, not only one relation, but maybe 2 or 3 relationships here. And if we predefine this kind of the decrease or the increase then decrease way, that looks much like the normal distribution, right? And if we just try to learn the parameters for this kind of the user intent, here we are talking about the user intent, then we could, in those ideal cases, based on those assumptions, we could build some really nice model. For example, here we call this model as the chorus, and in this chorus model, we model the complement information, substitute information, and also the user's purchase time. Is it just bought or is it long ago? Then we will find the different impacts to the current work. Then we learn different embeddings. So you just think that it's just kind of the chorus. Everyone have its voices, every factor have its voices here all together. When combining, integrating those voices together, and we have a very good chorus, and very good recommendation for the users. I do love this kind of the model, and we try to combine different things. And what we need to do is just to estimate the parameters here. So that work is also has been published on SIGIR, and I would just skip the details about this model. But actually, when the students have done this work, when he's really proud of this work, also proud about the model name chorus. What a perfect name, and what a fancy, a beautiful model. Yes, I agree. And then sometime I discuss with my student, is that the users, can we model all kinds of things? Is it good enough? Is it the truth, what we have in the reality? Well, the student go back to the data, and okay, I just forget about this result page. So actually, you will know that really encouraging result can be achieved. And then, is that the truth? My student go back to more scenarios, not only the e-commercial, but also, for example, we use the REXIS 2017 data. It's a job posting and job recommendation task. You will find that in 2 different cases, here are the true data distribution we got from the data. That is what data tells us. So from when we go back from the ideal world to the reality, we find that, well, for example, this is the Amazon electronic data set. It's an e-commercial website. We find that even for this, it looks like that the user intent distribution is simplified, something like the school normal distribution. We always love normal distribution. It's so powerful, but actually, we find that it is dynamically changed. Well, for example, here the blue one is also by. Also by means it's kind of the complementary products, and also view, but that maybe doesn't buy. That's kind of the substitute relationship among the products, basically. So you will find that so actually for also by relationship, people will have some short-term effect, and for the long-term, for the also view for the substitute um, items that they have the long-term effects. So you will say that here, although it looks really close to each other, but actually I have marked that the gap between them is even reached to 1.5 years, so that the user's intent changes dynamically for different relations. So that is kind of the bad news that makes our model more complex. And for job posting, things are even worse because you say, oh, we don't say it's a normal distribution. That is a multi-model pattern, maybe a multiple normal distribution. That is kind of the not a good news, because how many normal distributions do we need to integrate them? And yes, here we also find there are some short-term, long-term effects different with different users' intent. For example, for short-term, the people are more focused on the shared region jobs. People are hunting for the job in the same region. But for long-term, people are more interested in the shared industry. Maybe even if it's not in the same region, it's okay. I'm just want to have the breakthrough. Maybe that's a new milestone in my life. And then I don't care what city it is or what region it is, but it is what my expert domain, some kind of thing. So that changes greatly. Well, that is kind of the complex model. And that is just one scenario. How about other scenarios? Is it possible? We don't think actually we don't think it's possible to give the predefined distribution and just learn the parameter. It's not the way we want. So you see that is kind of the a bit to PhD students. You know that when they find, firstly, you are proud about your model, you're proud about your very beautiful, nice model and encouraging result, and then you found it's not the truth. It's far away from it's a little bit far away, or it is just focused on one domain. The generalization ability is not so good as you expected. What kind of disappointed thing? But actually, thanks for Chen Yang, who is somewhat really not just beat down by this bad news, and he think about over, is it some way, and is it some mathematical tools that we can borrow and we will be inspired from, that we don't need to predefine the distribution just to learn the model, and then we think about the Fourier-based temporal dynamic modeling. Well, actually, you know that basically we have some users' intent distribution in the time domain, but actually what we got is kind of the discrete distribution, discrete calculation, discrete counting about the user's purchase behavior, but that's just part of them. Is there some link between the continuous domain, time domain, to the discrete domain? Yes, you must also thought about this Fourier, the powerful mathematical tool, the Fourier transform. And then we can, by the Fourier transformation, we could just, firstly, we just use the original time interval distribution length got from the data, and then by the DFT, just the traditional way for the Fourier transformation, the learning initialization, we got a learnable frequency embedding for our items and for the user intent. So that is a complex frequency domain. And then we could use that. Why we use the Fourier transformation? Because it can be transformed from the time domain, continuous domain to the discrete domain. And it also is able to recover from the discrete domain to the continuous time domain. And then when we get a really good embedding, you know that our neural models are really fancy and powerful to learn the good embedding. And then when we got the good and learn pretty well learned embeddings, and then when we do the IDFT, the inverse DFT, and then we could find recover its time for the continuous time distribution in the time domain. And then that is a really powerful way. And that is, I think that the most beautiful part and most elegant part for this work. And then we build this kind of the model. And well, for each relationship now, we have extended from 2 relationships to multiple relationships. And most importantly, for each relationships, we could learn the distribution adaptively and dynamically, because that will change by the time, and we learn that embedding, and we got that time variance distribution for each model, for each relationships, and we got that. We embedding that information into our recommendation system, recommendation scenario, and then we got pretty good result. And this work has been, that is one step further from our WW19 work to SIGIR 20 work to now it has been published on TOIS 2021. And I will just give the other details about that. And yes, we have very good result, and the really significant improvement has been achieved. Well, what's most important, now we are able to model the complex intent, user intent, and dynamically and adaptively. We don't need to predefine the model, and this is dynamically changed via the time. This is the comparison for different way approaches. Here is a true distribution we got from the data for the test data, and here the blue lines are the ones we can learn from our final model that just we almost perfectly match the trends. Although it is a little bit different, but the trends has always been perfectly matched. And for this one, for this green, for this orange ones, that are the it is driven for this one. You know that we have, firstly, we have the DFT-based initialization. Yes, actually, you can use this original data distribution directly here to learn, but without the DFT distribution, DFT learning for initialization, then when we got the random initialization, then we got these orange lines. Actually, it's not as perfect as our final way, but actually it can also capture some trends about increase and decrease. And the green line is kind of the thing that if you model, if you provide a distribution previously, a fixed distribution and just try to learn the parameter, then you will get this green line result that's far from what we wanted. And that's just from ideal case to the reality. So till now, we find that, yes, we could get an encouraging result answer to that part. Yes, we are able to model the user complex intents. Oh, I'm afraid that I used too much time. And is it possible, okay for me for another 5 to 10 minutes for the third question, or it's better to stop here?
I think we can do another 5 minutes. So if you want to keep going, let's do 5 more minutes and then we'll stop for some questions.
Okay, no problem. I will finish in 5 minutes. So actually, the last question, yes, I only have 3 slides. So the last question is that is users' preference a secret and only known by themselves? You know that previously everyone believed that user preference is subjective and it is personalized thing. So we have to rely on user feedback like the click and then we will have some precision bias, selection bias, exposure bias, quite a lot of biases. And because we can't ask a user every time what you like or not. And people also observe the inconsistency between offline and online results. And now it's time for us to rethink about this basic assumption. Is that truth? Is it mission impossible to learn, to capture and to perceive the user's preference in advance? Well, actually, we design a user study. We ask user to visit, to check about the 20 movie and got their preference. That is the basic history information. And we gave that information to the accessor and they got those information. They don't have the direct connection with the users. When they got this information and then he check about some new candidates and he do some prediction about whether this movie will be preferred by the user or not, whether the user will like this kind of the movie or not. And then user will check about some recommender system comparatively, and they don't know which one is recommended by the accessors, and then user give them feedback on the preferences. Well, we got very encouraging result. Well, if for only one accessor, you will see that if the accessors and the users annotation is varies within 1, and then we got 77% of agreement between accessor and user self-reported feedback. That's really high, much higher than we had ever expected. And if we have 2 accessors, then this percentage reached to around 80%. And we have if we have 3 accessors and the agreement increased to the 81%, 81.7%. It means that, yes, external assessment will have agreement with the user's own feedback. And one step further, can we use this external assessment to help us to train our model? And then can it help us to improve the recommender system performance? And yes, you could say that these results are the rank for the settings, and then the evaluation based on the user self-preference. And this column are the evaluation based on the external assessment. You will see all of the trends are consistent with each other. And this one is based on the historical user history. What we use traditionally, yes, not surprisingly, the offline assessment, offline training have the different result compared with the online result, the first and the third column, but very encouragingly, external performance, external could. And then that is our conclusion, tentative conclusion. Well, we find that users' personalized preference can be perceived by other person, and it can be consistently accessed. Well, here the KL divergence is really low, so that we have reached the highest similarity by different annotators. And it can be used to evaluate the system and even better than historical based offline evaluation. But I will have to say that it does not mean we want to replace the large-scale log-based learning, but it will greatly helpful for us to do some proper external assessment for example, the new user, to deal with the cold start problem, and it can be combined with the large-scale log-based learning to So we feel that it reveals a new direction for understanding the preference, that it is perceptible and it can be accessed by external assessment, and it will help our evaluation. And this work is jointly, or it's a joint work between us and the Martin Dirac. He provide very good suggestions and comments to this work. Okay, that's all for our for my presentation. And we also we have also released some open source toolkits we feel that might help you. For example, the open source platform for the for recommender system, including the colors and the all kinds of the mainly the sequential recommendation model. And we also release the open source toolkit for user field study that we hope that it will make our field study in the community more easier. And it has been published in SIGIR 21 demo tab. Okay, that's all for my talk. I'm afraid I used too much time. Thank you.
Can we all unmute and give me the round of applause, please?
Thank you.